Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem minimum distance between BST nodes. BST stands for binary search tree. And before solving the problem, if you are not yet subscribed to Coding Charms, consider subscribing for coding and interview related videos. And in this problem, we are given with a root node of a binary search tree, and we have to return the minimum difference between the values of any two different nodes in the tree. Okay, we have to return the minimum difference between the values of any two different nodes in the tree. Okay, let's take a look at the examples. So in this example, we have this given tree, and what will be the differences between the nodes? 1 and 2 is 1. Difference between 2 and 3 is 1. Difference between 4 and 2 is 1. And 4 and 6 is 2. This is 2 as well. 4 and 2 is 2. And difference between 1 and 4 is 3. 4 and 3 is 1. So the minimum we can see is 1, right? Because we don't have the same nodes in the tree. And if we go down to the second example, we have this tree. The minimum we can see here is 1 as well. Here we have 1 and here we have 1. Since we don't have any same nodes, the difference can't be 1. So the minimum difference we can see is 1 over here as well. So we return 1. So how can we solve this problem? Before trying to come up with the solution, let us see what is binary search tree. So if we have a root node, let's consider the tree. We have a root node and we have a left subtree and we have a right subtree. The tree is said to be a binary search tree if all the nodes present in the left subtree have values less than root, and all the values in the right subtree have the values greater than root, and this is recursively true for each and every node in the tree, then it is known as a binary search tree. Okay, a tree in which a root node has values less than or greater than all the values present in the left subtree and less than all the values present in the right subtree. Okay, then it is called as a binary search tree. And so by this we can derive another property. The in-order traversal, there are 3 traversals in a tree, right? Pre-order, in-order, post-order. The in-order traversal, which means we go to left and then we go to root and then we go to right. The in-order traversal of binary search tree is sorted order. Is the sorted order of all the nodes present in the tree. So let us see that. So in this case, first we start at root node and we go to its left, and here we go to its left. Again, at 1 we don't have any left, so we go to the root node now. At the root, we write down the root node and we go to right. There is no right, so we go back to 2 and we print to 2 and we go to its right, and we are at 3 now, and we go to its left. Don't have any left, so we print 3 and then we go to its right. We don't have any right, so we go back to 2 and we go back to 4. At 4, the left tree is completed. Now that it's turn, so we print 4 and now we go to its right side. Right side is 6 and we go to its left. We don't have any left. We go to the root. Now we print 6 and then we go to right. There is no right, since we go back to root and we complete our execution. So this is the in-order traversal of this tree. Okay, what is the in-order traversal? 1, 2, 3, 4, 6. You can observe it is in the sorted order. Sorted order. So we can say in-order traversal of a binary search tree is a sorted order. Okay, we have derived this inference, and now let's forget about the BST and all for a moment, and let us see if you are given with an array, let's say a sorted array. Okay, to make things easier, we are given with a sorted array and we have to find the minimum difference between the values of the sorted array. So let us take the sorted array as 1, 2, 3, 4. Not 1, 2, 3, 4. Let's take something as 1, 2, 5, 10, and 15. So what will be the minimum difference between the any two values in the sorted array? So what is sorted array? All the elements are present in the increasing order. So the two elements will be the nearest elements, right? 1, 2 are nearest, then 2, 5 are nearest. The difference between them will be the nearest difference possible to any other integer, right? One will be one's difference with 2 will be the smallest compared to all the other differences. So to calculate the minimum difference, we take the difference between two consecutive values in the array, and we take the minimum of all the differences between the two consecutive elements. So in this case, 1, 2 is 1, and 2, 5 is 2, 5 is 3, and 5, 10 is 5, 10, 15 is 5 as well. So the minimum is 1. So similarly, what we are doing here, we are calculating, we are starting we are calculating between two difference between two consecutive values, the current value and the previous value, and we are taking the difference and we are maintaining the minimum difference. So in this problem also, we will do the same thing with the binary search tree. While performing the in-order traversal, we keep track of the previous node's value, and we already know the current root value. What we do is we take the difference between them. We take the difference between the current root value and the previous value, and we also keep track of minimum difference, which keep tracks of minimum difference between the two values, current root value and the previous value. In this way, we can compute the minimum difference between the two nodes in the given BST. So let us see that. Let us code it up. Let me take the variable result. Initially it has int max, and let's take previous variable and let us initialize it to -1. And now let us take a helper function, minimum difference in BST helper, and it takes the root value, and yes, and we return the result. Okay, and let us code the minimum helper function. So it doesn't return anything. Minimum difference in BST helper. What this basically does is the in-order traversal. So let us code the in-order traversal. In in-order traversal, what we do? First left, then root, then right. So first the root value should not be null. If the node value is null, then we return. If the node value exists, then we go to its left. So minimum difference in BST helper roots left. Now we have completed left. Now we are at root. What we do at root? We compute the difference, right? If previous value is not equal to -1. So if the previous, at root, we don't have to perform any difference. The previous value doesn't exist. So if previous is not equal to -1, then what we do is we take the difference, right? And we compare it with the result. So result equal to minimum of result comma. Now we have to take the difference. Root value minus the previous value. This gives the difference, and we calculate the minimum result. And next, what will be our previous value? Our previous value will be equal to the current value. Right. Now we go to the left. Minimum difference in BST helper root. Right. Looks good. So what we are doing, we are using a helper function to compute the result. And in this helper function, what we are basically doing is in order traversal. First, we are checking if the root is not null, and we are going to the left, and then we are going to the root. At root, what we are performing, we are taking the difference between the current value and the previous node's value, and taking its difference and keeping track of the minimum difference. And next, after completing the execution of the current root, we are considering it as the previous because we are moving on to the next node. And then we are moving on to roots right. So this is the code. Looks good to me. Let us run the code. And it passes all the sample test cases. Let us submit it. It passed all the test cases. So what will be the time complexity of this approach? The time complexity of this approach will be normal DFS or the in-order traversal time complexity, which is O of n, where n is number of nodes in the BST. And the space complexity will be O of n as well, because O of n as well because we are using recursion. The recursive call stack will be at most O of h, and the height of the tree. Height of the tree in worst case can be the number of nodes in the tree if we have linked list kind of a tree. So time and space complexity is O of n. I hope you have understood the solution and the time and space complexity. If you did, make sure you hit that like button and subscribe to Coding Champs for more coding and interview preparation related videos. See you all in my next video. Till then, take care, keep practicing. Bye bye.